Hey game makers, Pixelated Pope here, and today we're doing something just a little bit different. You may notice I got the webcam on. That's different. So today I was helping Reddit user SlipperyJim8, who you may remember from my episode 2 of Pixelated Pope Private Investigator. He's working on like a digger game, kind of 2D Terraria. Not really sure. I've never played that type of game. So he was working on getting chunks of his level to load in and and unload, so he doesn't have a billion instances all running at the same time in his game. And he reached out to me for help, and so I sat down, worked on it a bit, and came up with a way to do it. And I just kind of sent him the GMZ and said, "Here you go. Good luck with that." But I thought it'd be a good idea to take some time to walk through the process I went through and go through the code and kind of explain every line. So really this video is kind of for an audience of one. It's really intended just for SlipperyJim8, but figure if anybody else wants to see it, they can see it and maybe they'll learn something from it. So let's look at what we got. So there's a few things about Jim's project that makes things easy. First off, as far as I could tell, it's just a single column of dirt, of things to mine. So you can't move left or right. You can only move up or down. That really simplifies this whole chunk loading of dynamically generated content. So as I scroll up, that's the top of our land, and I can scroll down and we get this randomly generated land. But it's not just randomly generated. You might notice I've got some pretty intricate patterns in there, and I can go through and delete things and then scroll down, and then when I scroll back up, they're still deleted. You may also notice the count variable here on the screen in the top left. That is the number of active instances. So you can see it drops pretty significantly to about 42 when I've got this on screen, and then it stays about 48 most of the other time. And that's just because things are unloading and loading back in, and so it stays pretty consistent, which is exactly what you want. You don't want all of these instances activated at the same time in your game when there's really no reason for them to be active. So that's what we've got. So where do we get those patterns? Well, that was part of the requirement, is he wants to be able to design these patterns that can be challenging. The obvious solution, or the most simple solution, the most desired solution, is to use the room editor. So you just design these patterns, and then you can copy them out of rooms and get the patterns to place in your game wherever you want. So that's what we've got. I've got just a bunch of rooms in here that all have patterns, and that one's really simple. It's a single line. They can be any height, but they all have to be 6 wide because that's the width of his his world. I mean, he can make it whatever width he wants, but it needs to be consistent. But the height, since we have infinite scrolling height, it doesn't really matter. They can be as tall as you want, as intricate as you want. So that's kind of the requirements that Jim was working with. Is he wanted to be able to design his own rock patterns, be able to scroll down infinitely, as far as I could tell. There wasn't a bottom discussed, and then have objects unloaded and loaded as appropriate, and any changes to those objects would be preserved. So how did I do it? So it all starts here in room start. I've got one object world manager. I do this a lot in my games. I have a single object that controls the spawning of pretty much every other object that you'll ever see in my game. This way, I don't drop a lot of objects in rooms and have to mess with room instance order. I have full control over when instances are created, what order they're created in, and I can guarantee that specific instances have been created before other instances and rely on variables in those instances being available to that object. I do this a lot. The room width and height doesn't matter because we're going to set the view and scroll way outside of the room boundaries. So I just went with 256 by 256 and of course a room speed of 60. So everything revolves around this object world manager. So let's go take a look at him. So right off the bat, first thing we do is I grab a randomize because we definitely want things to be random every time. And I start setting up some sort of constants, not really constants, but just some variables that I'm going to use to define the world and how we're going to keep track of some things. So we got our world width, which is of course the 6 blocks wide that we're dealing with, and world height. I use this later to define the size of the view. I just wanted, at least 4 blocks on screen at once, plus or minus a little bit. But eventually this could be replaced with a calculation based on his desired view height for how many blocks he wants on screen at once. And then we'll amend that with load border, which is the next most important thing, which is how many rows above and below the visible rows where our view is, we're loading in and keeping active. And this is just if you got a really fast scrolling view that's moving multiple rows at a time, you may want to kick that way up so that you're always ahead of the curve. Then I've got my grid. So the whole structure is a data structure grid. It's just a 2-dimensional array, essentially. I like using grids. They've got a lot of cool functions that we're actually going to take advantage of that make them more versatile than just a plain array. But that's basically what they are, just a 2D array with functions built around them. So that's the structure. So these other variables are for how we load things in. First off, as we're scrolling, we don't want to just constantly be checking to make sure we're, have we spawned everything we need? Have we spawned everything we need? Better go check. We only care about it when the view is changed. If the view hasn't changed, there's no reason to go to the data structure and start looking for, are we in bounds? Have we moved? We know when we've moved and when we should be loading or unloading things. So this variable will keep track of that for us. And I recommend anytime you're doing something, always ask yourself when you're coding, how often do I really need to do this? And, does it really need to be done every step? Does it really need to be done every other step, every 4 steps, every 5 steps? Could I do this once every 30 seconds? Or is there a specific trigger I can wait for before I do any of this? In this case, the view moving is the only reason, I would need to update any of this. These next 4 variables are all kind of define the boundary of where we're loaded. So top Y 0, that's just the top of the grid, and then top Y previous, that's a -4 right now because I'm going to go through, from 0 to the bottom of the screen to bot Y. So I use -4 a lot. It's also no one. It's the exact same thing. I use that as sort of in other programming languages, you might set it to null. We don't have null really in GameMaker, so I use no one. Although you got to be careful with that because it's not null, it's -4. So since I'm talking about coordinates in a DS grid, a negative number should never be used. So it's safe to use no one here because I'll get a whole bunch of spam in my output window if I'm using a negative number to reference the coordinates of a DS grid. So these are all the properties we're going to be using for loading in the grid and keeping track of the grid. So let's look at the rest of this code block. So this is the list. There's not much in here. Every one of these rooms is going to get converted into something that can be used, and I'm going to store those somethings in this DS list. And then I probably could have just put this in the next block. We're going to the next room. So the order of these rooms is pretty important. This is our initialization room. And then immediately after, we have all of our pattern rooms, all of the rooms that have our patterns in it. So that'll be the next thing we go into. So when I say go to the next room, we start hitting our room start events. So initially, we set up our views in the room. I guess I don't need that breakpoint anymore. And you can see here I'm using a macro called tile size. So if he decides to change his block to 16 by 16 or 64 by 64, this will all still work. All he has to do is change this to something else to match his art. So I do that a lot. Constants, they used to be called constants in an older version of GameMaker. Use macros for things that just won't change in your game, and you want to be able to get like the whole autocomplete and coloring text. It's really nice for things that don't change. So we set up our view. Again, I use the tile size times the world width +2. So we get the 6 blocks plus 1 plus 2. So it's a little bit wider. And then I take the view and I offset it by 1 tile size so that the view's centered. It looks centered on the column of ground. We set it enabled, set it visible, and there's where I set the minus a tile size. So really our view is actually out of the room a little bit to make everything appear centered while still keeping our coordinates simple. 0, 0 is the top left of the first brick in the top left corner. We'll get to that in a little bit. And then I set the size so it's a little bit bigger, set the display size, or the GUI size, and then resize the application surface to match the view size. And here's the real work. So if our room is not room main or room start, so that means it's our pattern room. And as you add more and more rooms, this will get more and more complex. So there's probably a better way to do this. But this is just a simple example of how you might do it. So I create a grid. So every one of these patterns is going to get turned into a grid. And I initialize the grid to no one. So if there's no dirt block there, it'll be in -4, no one. First, we see what's the tallest block. And so we've got 1, 2, 3, 4 rows here. So if my y divided by tile size, which would be 0, 1, 2, 3, is greater than or equal to the height, then we resize the grid. So I make sure the grid is the right size, and then I have every block set its own object index. So the type of block it is, you can see all my different types of blocks here. Got a parent and then the different types. And there's nothing in here. Like these are all just empty sprites, basically, that are just blocks that are different object indexes, and that's the only difference for now. I mean, obviously, in the real game, you would have different things happen based on breaking gold over breaking rock, but that's really like that's kind of the crux of this whole thing. Is you have a DS grid, and what's in the grid? What's in every individual cell of that grid? Well, it's either -4, no one, if there's no instance supposed to be there. So that would be like air or place you've already mined. Or it would be the ID of an instance or an object type. So the ID for object dirt, the ID for object rock, the ID for object gold, etc. So we then have this DS grid we just created added to our pattern list, and then we go to the next room and we go through as many. You can have as many of these as you want. You define as many as you want, and they'll all get put into the pattern list. Now we have all of our patterns, and we eventually make it to room main, and we've stopped indexing the rooms and we stopped going to next rooms. So we stop at room main, which is totally empty, right? Because this is our world manager is a persistent object, so it's the only instance we need right now. So what does it do once it gets to this new, main room? That's where the step event starts to come in. You can see the first thing I do is, are we in room main? If we're not, just break out of the step event. Exit will break out of the entire event. So none of these code blocks will get hit because I said exit at the very top. So if we are in room main, then we check the controls. So I can scroll the speed using VK up and VK down. And if either one is pressed, I say view update equals true. So this is where we're keeping track of if the view is moved. And now we get to the really intense stuff. So this is where we update the visible instances as the view changes. So we only do this if our view updated. Otherwise, we just skip this whole thing. There's nothing in here that gets run if we haven't updated the view. So the first thing we do is we update those top Y and bottom Y variables. So I use max here because you never want max 0, because you never want a negative number. We're going to be using this top Y and bottom Y to find coordinates in a DS grid. Can't have negative coordinates in a DS grid. So max is 0. If this is a negative number, we're going to get 0 back. So, and then bot Y is also max because we want the furthest one down that we know we need. And that's either going to be our basic, the first time we load up, we're seeing from 0 down as big as the screen is, which is world height plus our load border. So it'll give us a little bit further down. But usually we'll be using this one, which is wherever our view is, plus the height of our view. So that's the bottom of our view's room coordinate position divided by tile size. And then we round that up using seal. So that'll give us the bottom coordinate that we should be using. So this is where we create the new terrain. So if our top Y does not equal our top Y previous, then, and we'll update top Y previous a little bit later, then we know we've moved, we know we've actually changed coordinates that we're looking at, and we need to load in new terrain. So while DS grid height world grid is less than, so this is where we actually say, okay, our DS grid height is not as high as the coordinates that we've asked to load. So you're saying you want, the view should be loading in row 6. We don't have a row 6. We're only up to row 5. So we need new terrain to be in row 6 and maybe beyond. So we call this event user 0. So I use user events a lot for any of you familiar with other programming languages. This is the closest thing to like built-in methods. We have private methods for an object in GameMaker. So nobody else in any other object in this entire game is ever going to need to do this thing that Object World Manager is going to do. But I didn't want it also, since it's complicated code, I didn't want it to be in line with the rest of that complicated code. So I broke it out into its own user event. Didn't need to create a new script, didn't need to mess up, clutter up that code anymore. And it's now in a nice reusable place in case anywhere else would have, anywhere else in the object needed to be able to create more terrain. So it's actually not too complicated in here. But what we do is we grab a random pattern using irandom and a pattern list, a list accessor. And then we get the height of that pattern, and then we get the height of our current world grid, and we store this as our previous Y. This is where basically the height is going to be the row that we build our new terrain on top of. So we resize the grid with the new height using the previous height plus the height of the new pattern, and then we use one of those cool built-in DS grid functions, DS grid add grid region. And if you're not familiar with this, basically you can take a section of one DS grid and then paste it into another grid, which is really cool. You just, wherever it's from, you just take it, plop it in, and it goes where you tell it to. Very, very powerful. So we just take that pattern grid and just drop it in at the bottom of our world grid. So that's how we generate our terrain as we scroll down. So coming back to updating, so now we've done this. So usually this should only happen once, but if you do a huge jump, say he wanted to start his view, 60 rows down, this one while loop doesn't care. It'll say, oh, you wanted to start at 60 down? I'll just keep building terrain until wherever the bottom of the view is, we're done. We've built all of the terrain up above us, which is pretty cool. So now, really easily, we just say with object block, if you're above above the screen, you're out of the screen above or out of the screen below, then destroy yourself. Just kill yourself. You're done. And we'll load you back in when the view moves up and down. So every time we move, we just clear out the old instances, and now we need to go through and create the new ones. And this is where things get a little complicated. And I'll be honest, even when I'm thinking about pulling data out of a data grid and moving views and using rounding values to make sure I'm looking at the right row and loading the right number of rows in, it gets confusing. Gets really confusing. And don't feel bad for getting confused by looping through a data structure and trying to pull the right values out. I did this through guessing, kind of getting it right the first time or getting it close to right, and then adjusting some values with trial and error, just making sure I was getting the results I was expecting. So we basically have two possibilities here. You're either moving down and you need to create instances at the bottom, or you're moving up and you need to create instances up above the view. So we've got our two blocks here. So we know if our bot y previous is less than our bot y, then it was here and now we're here. So we're obviously moving down. So we loop through, starting, we find our y previous plus 1, because we'd already loaded y previous previously because we have a less than or equal to bot y in this for loop. This, like I said, this is where things get really confusing. So we start at a row that we last loaded, and then we go through each row. So we go down to the row, and then we go dunk 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 dunk, and we load in each tile that is in the DS grid, each block that is in the DS grid, and that's what this instance create is. And it just pulls its object index right out of the grid. So it's really easy. The grid itself is very simple. And we do the same thing going up. If we're moving up, we say, okay, let's start at our y previous, but minus 1, because we're moving up and we'd already done top y previously. And then same thing, go through each cell horizontally. And if we're not if we're greater than or equal to 0, so we're not going into the negatives, and an actual instance, if the block says I'm no one, then you don't need to create anything. Otherwise, we'll have an object instance that an object index that we need to create. And then we just update our top y and bot y previous so that we know if we've moved and we know which direction we've moved. And that's it. That's kind of the whole thing. I know this was kind of scattered, but like I said, this is kind of a video for an audience of one, and hopefully that explains some things about the process for doing this. There are a million ways to do this. Like, you didn't have to destroy instances at all. You could just deactivate and reactivate, and then you're just activating and deactivating a small region around your view. Maybe that's easier. The cool thing about this method, though, is that by having a grid, you can save this. You can use dsgrid write it out to a text file, and then load it back in and get the exact same structure up until, as much as you've generated, right back the way it was before. The power of dsgrids. Hopefully this was at least a little bit informative, not too rambly. Yeah, thanks for watching. Go make something awesome, all that jazz. See you later.